Alright, so now we're getting a little more complicated here. I want to know what's the maximum static friction coefficient that we can have before this system stops moving. So first, let's imagine what would happen if there was no static friction. So if there was no static friction, we've done this problem already. We have a 150 Newton force pulling down this way, and we have total mass of the system equal to 30 kilograms. So the result is F net equals ma, and so 150 equals 30 times a. So the acceleration of the system would be 5 meters per second squared. So if there was no static friction force, then we would have an acceleration of 5 meters per second squared, which means that what's happening here is the tension in this cord here, right? The tension in this cord here, which hopefully after two problems with a massless frictionless pulley, you will now agree is the same as the tension in this cord here. This tension is what's causing the system to accelerate. Alright, so if we look at this object here, we get that F net equals mass of the 15 times A of the 15. F net is going to be 150 minus tension, which will equal 15 times 5. So tension will equal 75 newtons. Alright, so the tension in the cord will be 75 newtons when this system accelerates. So the result is that then we can see what happens when this accelerates. We need our friction force to be no greater than 75 newtons. Right, so friction, our static friction force, which is going to pull back this way, can be no greater than Fs max, can be no greater than 75 newtons, because that's what's going to be pulling in the opposite direction. So the result, if Fs max has to be less than 75 newtons, Fs is mu times the normal force, and mu we don't know, we're looking for it. The normal force is 150 kilograms, or newtons rather. So our maximum static friction force, in order to get it to keep moving, is going to be 0.5. At a static friction force of greater than 0.5, we just will not have enough tension in the cord to move it. At less than 0.5, we're not quite going to have this 5 meters per second squared of acceleration, right? Because we'll have some backwards force pulling back. But at anything 0.5 or greater, we will have no motion of the objects.